This is the homework helper for Chapter 5, Section 3 in the 8th grade textbook entitled Dimensional Analysis. Alright, the first 4 questions all guided with the same direction, and that direction is to convert the measure. So, in number 1, they're asking us to convert milligrams to grams. Now, as you recall, as we talked about in class today, ever with me have we ever done milligrams to grams with any type of fractional conversion or anything like that. We've always used that list of metric prefixes to make the conversions. In case you've forgotten those, they're again on the board already for you, right above the directions there. When we're converting from milligrams to grams, we're going from milli back here to grams, which is in the middle. Well, that's 1, 2, 3 jumps to the left of my chart. And remember, how many ever jumps it is and in what direction is the same thing we do to the decimal. So I'm going to take and move my decimal 3 times to the left as well. So I'm going to go 1, 2, 3 to the left, and I end up with 0.3, as in 0.3 grams. And that's the only question we'll be able to get away with that on. For everything else, we're going to have to make a T-chart and solve accordingly. All right, number 2, we're converting 500 yards to feet. All right, so we're going to set up our T-chart here. Remember, when we do T-chart conversions, all right, most of the time this bottom box is going to be blank, unless we get to a question where it's like 60 feet in 2 hours, in which case it would be 60 feet over 2 hours. But otherwise, this box down here is going to be blank. This box up here is where we're going to put what we're starting with. In this case, we're starting with 500 yards. Now, over here on this right side, what's ideal is if I can put a conversion that involves yards and feet, right? Because the question is asking me to go from yards to feet. If I can't do yards to feet in one step, I want something that at least is going to have yards so I can get rid of the yards, but somehow eventually get to feet, like if I were to go yards to inches and then inches to feet. Okay, so the conversion here is known, though. It's that 3 feet is the same as a yard. So now it's just a matter of which one goes where. Well, remember, when we do T-chart conversions, units cancel diagonally. So if yards is up here, something with yards has to go down here to cancel it, just like we were reducing a fraction. All right, we're reducing a multiplication problem involving fractions, if you want me to be more clear. So something with yards here. So if it's 3 feet is a yard, that means the 3 feet goes up here and the 1 yard down there. And we see yards canceling yards diagonally. Notice what unit I didn't cross out. I didn't cross out feet. Since feet is still there, that's where I need to go. That's the unit I'm supposed to end up with. That's how I know I did this correctly. Remember what you do then is multiply across the top, multiply across the bottom, and divide the two. 500 times 3 on the top is 1,500. 1 on the bottom, 1,500 divided by 1 is 1,500. So 500 yards is the same as 1,500 feet. Okay, let's try number 3. 72 ounces to pints. So again, I'm going to set up my T-chart again, and in that starting block is going to go my 72 ounces. Now I want a conversion that involves ounces and pints. So that would be a good one to look at your conversion chart for. And you want to make sure you're using ounces in terms of capacity, not ounces in terms of weight. We know that because it says pint, really, is how we know that. That's got to be a capacity. Pints is never a weight. All right, so there's really only one good way to escape here. Ounces, and that's that 8 fluid ounces is a cup. So we're going to use that first here. 8 ounces in the bottom, 1 cup in the top. How did I know that? Well, remember, again, as we talked about in number 2, units have to cancel diagonally. So if ounces is up here to make it go away, the other ounce thing has to be beneath to make them cancel out. So notice I'm at cups now, but I need to get to pints. So now I'm going to use the next conversion, and that conversion is that 2 cups is equal to a pint. Since cups is up here, the other cups thing has to go down here. So that's 2 cups down here, and 1 pint in the top, And that's how we see cups canceling diagonally. Notice the unit I did not cross out when I did all that was pints. That's how I know I'm in the correct place. Remember, what I want to do now is multiply across the top, multiply across the bottom, and divide the two. So the top is 72 times 1 times 1, which is 72. And the bottom is 8 times 2, which is 16. So I've got 72 divided by 16. 72 divided by 16 should yield a result of 4.5. So it's 4.5 pints. 72 ounces is the equivalent of 4.5 pints. All right, let's go ahead and take a look at number 4, 7 quarts to gallons. So again, we'll set up our T-chart here with 7 quarts. Again, this upper left block is always where you're putting what you start with. Now we're trying to get to gallons. Well, if we look at our chart for capacity, we know that 4 quarts is the equivalent of a gallon. So that's what I'm going to write over here on the right side of my T-chart. Again, units have to cancel diagonally. So the 4 quarts in the bottom and the 1 gallon in the top. And I see quarts canceling diagonally. Notice the unit I did not cross out is gallons. Because that's where I'm supposed to end up. So the top is 7 times 1, and the bottom is just 4. So this is 7 over 4, or 1.75 gallons. In other words, 7 quarts is the equivalent of 1 3/4 gallons. All right, let's go ahead and take a look at number 5. Jesse's dog, Angel, weighs 18.5 pounds. How many ounces does Angel weigh? So again, this is another T-chart conversion. It's just in the guise of a story problem here. All right. So set up my T. I'm starting with 18.5 pounds, which I'm going to write as 18.5. And I want to convert that pounds into ounces because the question says, how many ounces does Angel weigh? So I'm looking for a conversion that involves ounces and pounds. Well, we know that 16 ounces is 1 pound. So that's my conversion factor I'm going to fill in the right side of my T-chart. I want to put 16 ounces in the top and 1 pound in the bottom. Pounds cancels pounds diagonally. Again, units always have to somehow cancel top and bottom or diagonally. Notice the unit I did not cross out is ounces. That's how I know I am where I'm supposed to be. The top is 18.5 times 6 now, or 18.5 times 16 rather. 18.5 times 16 is 296, and the bottom is 1. So this is 296 over 1, or 296 as in 296 ounces. All right, number 6, a roll of tape contains 32.9 meters of tape. How many millimeters of tape does the roll contain? So this is back to being a metric conversion like we did in question number 1. I just have to use that chart. I'm converting from meters, which is here where the question mark is, to millimeters, which is out here on the right side. So that's 1, 2, 3 jumps to the right on my metric prefix chart. So I'm going to take and do the exact same thing with the decimal. Move it 3 times to the right. So that's 1, 2, 3 times to the right. Yes, as you can see, we've got some empty jumps, so those are going to have to fill in with zeros, and we end up with 32,900 millimeters of tape. All right, let's continue on with question number 7. There are 2 types of lifts in the sport of weightlifting, the snatch and the clean and jerk. Winners are determined by the combined weights of the 2 types of lifts. In the 2002 collegiate weightlifting competition, Timothy Liansu from the U.S. Navy Academy competed in the 94 kilogram weight class. He lifted 100 kilograms in the snatch and 132.5 kilograms in the clean and jerk. What was the combined weight of his lifts in grams? So obviously we need to put these all into grams in order to be able to find their combined weight. So once again, we need those metric prefixes that we've worked with a couple times on this homework alone and that we started with last year. Here they are again. Starts with kilo, hecto, deca, and then the unit, either meter, liter, or gram, and then deci, and then centa, and then milli. These ones are all given to us in kilograms, the two that matter, the 100 and the 132.5. Well, to get to grams, that's 1, 2, 3 jumps to the right. So I'm going to take and move my decimal 3 times to the right. So that means 100 kilograms is 100,000 grams. And 132.5 kilograms, again, 3 times to the right there. 1 jump to get me over the 5, and then 2 empties. That's 132,500 grams. And so I'm going to have to add those up, and that's 232,500 grams, which is the combined weight of his lifts in grams. All right, number 8. A scientist uses 103.6 milliliters of blood for an experiment. How many fluid ounces of blood does the scientist use? All right, so we're going to set up our little T-chart here with 103.6 milliliters. And somehow I want to escape milliliters and get to fluid ounces. Now, if we look at our conversion chart, there's only really one way to get out of milliliters here, and that would be to convert that to